This audiobook will cover lessons 1 to 6 from the Geography Coasts booklet. Additional information was procured from worksheets and PowerPoint presentations. Lesson 1. Why are coastal landscapes different? Rocky coasts. These are steep and vertical and can be up to hundreds of meters in height. They are affected by erosion and are dominated by headlands, bays, cliffs, and wave-cut platforms. This makes them high-energy environments and are often retreating landward coastal plains. These are low and flat and are affected by deposition. They are dominated by beaches, spits, and coastal plains. This makes them low-energy environments and they advance seaward. How do coasts vary? Number 1. Eastern and southern coastal plains in Britain tend to be made of weaker and younger sedimentary rocks, for example, clay and sandstone. Number 2. A range of habitats from estuarine, where a river meets the sea, to mudflats and salt marshes. Number 3. Typically, waves are less powerful or coasts are sheltered, for example, the Irish Sea coast in Southport. Number 4. Northern and western coasts in Britain are often rocky due to their geology. Number 5. Stretches of coast facing the Atlantic Ocean, where waves are more powerful for much of the year, are high energy. For example, Cornwall and western Scotland. Number 6. Cornwall and the west of Britain tends to be made up of older, resistant rocks. Key definition. Geology. Resistant versus softer rocks. Erosion or deposition. These change the shape, also known as the morphology, and features otherwise called landforms, which you might find. Low V's, high energy. Low means sheltered coasts with smaller waves. High means exposed coasts with powerful waves. Emergent V's, submergent for example, changes in sea level. Emergent is when the land rises relative to the sea. Submergent means sea rising relative to the land, for example, flooding due to rising sea levels or subsiding land. Tidal range can range massively from a few meters to well over 5 meters over the course of a day. Primary V's secondary. Primary is dominated by land-based processes, for example, deposition from rivers. Secondary is dominated by marine, otherwise called sea, processes. The littoral zone is the boundary between the land and the sea. First of all, you have the backshore. This is usually above the influence of the waves and is adjacent to a beach's cliffs or dunes. Then you have the foreshore. This is an intertidal or surf zone. Next, there is the near shore, otherwise called the breaker zone. Lastly, there is the offshore. This is beyond the influence of the waves. Lesson 2. How do geological structures affect coasts? The coastline of Devon and Dorset, named for the geological period in which its rocks were formed, the Jurassic Coast, is a World Heritage Site full of fossils. The Lulworth Crumple is a huge chunk of limestone that has been folded by tectonic forces about 30 million years ago. Geology refers to types of rock. Lithology is a broader phrase which includes types of rock and also geological structures, which are features such as points of weakness found in rocks. They include the following: strata, the layers of rock; bedding planes, natural horizontal breaks in strata representing gaps in time during rock formation; joints, vertical cracks caused by contraction of rock or tectonic uplift; folds, tectonic activity causing rocks to buckle and crumple; faults, when stress exceeds the strength of a rock, it fractures along fault planes; dip, the angle of rock strata, for example, horizontal, vertical, seaward or landward dipping; bedding planes. These are natural breaks in strata representing time gaps between periods of rock formation. Differential rates of erosion may create ledges between alternating strata. There is a risk of undercutting if softer rock is at the cliff foot. Joints, vertical cracks or fractures caused by contraction or by tectonic forces during uplift. Folds. These are formed by pressure during tectonic activity, causing rocks to crumple, especially when they are softer and less resistant. Faults. These are formed when the stress on a rock exceeds its strength and causes it to fracture and slip along a fault plane. Lesson 3. How does geology affect rates of coastal recession? Unconsolidated. Loose sediment that has not been consolidated, for instance, sediment which is put under pressure to compact it and lithify into a rock, more vulnerable to erosion. Permeability. The ability for fluid to flow through a rock. Porosity. The size of pore, otherwise called empty, spaces within a rock between grains. Geology and lithology are important in understanding the rate of coastal recession. Unconsolidated glacial till, such as at the Holderness coast, moves 1 to 10 meters per year. Sandstone, such as in Devon, moves 1 centimeter to 1 meter per year. Limestone, such as in Dorset, moves 1 millimeter to 1 centimeter per year. Granite, such as in Cornwall, moves 1 millimeter per year. The resistance, or whether a rock is consolidated or not, of a rock will affect whether it is vulnerable to erosion, weathering, and mass movement. The construction of the Aswan High Dam on the River Nile in 1964 reduced sediment volume from 130 million tons to about 15 million tonnes per year. Erosion rates jumped from 20 to 25 meters per year to over 200 meters per year as the delta was starved of sediment. Dredging. This is the removal of sediment from a beach, sea or river. Dredging can have devastating consequences for coastal towns because of the increased erosion. Hawsons in Devon, UK, was destroyed as a result of a dredging operation carried out in the early 1900s. The bay in front of the town was dredged, resulting in the beach all but disappearing over a year. With the beach gone, a storm during a high tide breached the coastal defences and destroyed the village. Which rocks erode the slowest and which rocks erode the fastest? Number 1. Less resistant rocks such as clay bedrock, slight seaward dip, slumping and rockfalls. Number 2. Weak geology such as unconsolidated boulder clay, joints and coal with a less resistant stratum. This can lead to undercutting. Number 3. Sharp seaward dips. Marine erosion along lines of bedding planes leads to the sedimentary rock shearing off. Number 4. Resistant limestone with horizontal dip, jointed, which has led to creation of erosive landforms. These include caves, arches, stacks and stumps. Number 5. Strong geology such as unbudded resistant igneous rock. Fault lines at right angles to the sea creates resistant steep slopes with no lines of weakness, particularly joints or bedding planes. Lesson 4. Concordant and discordant coasts. A concordant coast is where bands of more or less resistant rock run parallel to the coast. Because these rock types alternate, for example, the limestone may be in front of the clay. When a resistant rock is eventually eroded, it allows the sea to break through to less resistant rocks further inland that erode more quickly. At Lulworth Cove, a bay has formed from erosion, firstly through resistant limestone into much less resistant clay. Dalmatian coasts are a type of concordant coastline that form as a result of rising sea levels. Valleys of less resistant rock and ridges with more resistant rock run parallel to each other. When the valleys flood due to sea level rise, the tops of ridges remain above sea level, creating a series of offshore islands and flooded valleys parallel to the coast. The best example of this is the Dalmatian coast in Croatia. Coves form where rock runs in bands horizontal to the direction of wave attack. There is a band of resistant rock closest to the sea and a band of less resistant rock inland. The waves seek out faults in the hard rock and erodes using the processes of abrasion, corrosion and hydraulic action through to the soft rock behind. Wave processes erode the softer rock behind. Wave processes erode the softer rock faster, and this leaves a circular cove with a narrow entrance where the sea enters. The waves are also refracted within the cove, spreading out to erode in all directions. A good example of this is Lulworth Cove. Half coasts also have concordant features of long spits of sand with lagoons, water trapped behind, aligned parallel to the coast. They are named after the halves, lagoons of the southern shore of the Baltic Sea. A discordant coast is where geology alternates between bands of more and less resistant rock at right angles to the coast. At the Isle of Purbeck's eastern coast, more resistant rocks, limestone, emerge at the coast as headlands, and less resistant rocks, such as clay, form bays in between the headlands. At the Isle of Purbeck's eastern coast, more resistant rocks emerge at the coast as headlands, and less resistant rocks form bays in between the headlands. Geology creates alternating headlands and bays. Unconsolidated sands and clays erode quickly and have formed a large bay at Studland. Chalk is resistant to erosion and forms cliffs and headlands. Unconsolidated clay is a less resistant rock and has created Swanage Bay. Limestone is a resistant rock that has led to the creation of headlands at Peveril Point and Durlston Head. However, the limestone is jointed, which creates lines of weakness that can be more easily eroded in places. Lesson 5. How does vegetation affect coasts? Many coasts are composed of sand and shingle. This is loose, unconsolidated sediment that is easily eroded and transported. Low-energy coastlines may have beaches with sand dunes, created by sand that has been blown off the beach by onshore wind. Dunes form where sand is initially trapped by debris on the backshore. Plant succession helps to stabilize dunes, which become a rich habitat and a natural form of coastal defense against sea level rise and flooding. A small embryo dune develops. Tough plants like limegrass, sea couch, and marram grass develop. These are pioneer species which first colonize the coastline. Presence of shells makes sand more alkaline. Calcium carbonate increases pH levels. 1. These pioneer species begin the process of plant succession. 2. Pioneer species modify the environment by binding sand or soil with their roots. 3. They add nutrients when they die and decompose. 4. Creeping plants or leafy plants help the sand or mud in dunes or salt marshes retain moisture. 5. These changes allow other species to colonize the dune, and these invaders also modify the environment by providing shade as well as improving the soil. Yellow dunes or foredunes are the next step after embryo dunes. They are bigger and are found across Britain's coasts and may be dominated by marram grasses. Dunslacks are depressions between dunes and are damp areas where the water table is close to or at the surface. Mosses, reeds, rushes, and willows will thrive if there is enough moisture. Further inland, the pH is now reduced and there is more shelter. More plants can be found on these more stable dunes. For example, mosses. A layer of humus develops as plants die and decay, creating grey dunes. Lichens, mosses, and flowering plants begin to appear along with red fescue grass, creeping willow, and dewberry. Dunheath develops with plants such as heather, gorse, and buckthorn because of the more acidic soil, which is rich in humus and retains water. Woodland or mature dunes. The rear of the dunes are now colonized by tree species such as pine, birch, and oak. This stable, final community suits the climate of the area and is known as the climax community. This whole sequence is called a samosere, the plant succession found on sand dunes, beginning with embryo dunes and ending in a woodland climax community. The pH level decreases and becomes more acidic as the dunes mature. A plagioclimax forms when human influence prevents an ecological community from developing any further. The climax community is not reached and a different environment is created, often due to the introduction of other species, such as grazing animals and the cutting or burning down of vegetation. Blowout. Vegetation plays a major role in stabilizing sand dunes, but if it is removed, strong winds can pick up sand and transport it elsewhere. A hole is created in the surface of the dunes. This is a natural process. Pioneer species such as marram grass are vulnerable to damage from strong winds at the coast. Lesson 6. How does vegetation affect coasts? A salt marsh is an area of periodically flooded, low-lying coastal wetlands. Salt marshes are areas of flat, silty sediment that accumulate around estuaries where a river meets the sea, or lagoons, a body of water trapped behind a barrier beach, spit or bar. 3 conditions help to create them. Sheltered areas where deposition occurs. Places where salt water and fresh water meet. Locations where there are no strong tides or currents to prevent sediment being deposited. Salt marshes are covered at high tide and exposed at low tide. They are common around Britain's coastline. However, how do salt marshes form? 1. Salt-tolerant plants begin to colonize and stabilize the mudflats. 2. Halophytes, for example cordgrass, spartina, eelgrass, help to slow down tidal flow and trap more mud and silt. 3. These are the pioneer species of salt marsh formation and plant succession. 4. The mud is covered by water less frequently and subsequently the rain washes out the salt. 5. As plants die and decompose, they increase the fertility of the marshes. 6. As sediment accumulates, the surface dries and different plants begin to colonize. 7. Sea asters and meadowgrass grow. 8. Creeks, created by water flowing across the estuary at low tide, divide up the salt marsh. 9. The plant succession formed over time is called a halosea. In case you do not know, a halo refers to salt,